All right, yeah. As like I said, we're kind of do this project through SAP Architects, and my mother's name is the Arnhild Pálmadóttir. She's the owner and founder of the office, and I'm Arnar Skarp. And so our project is called LavaForming, and in our search for the most natural and sustainable building material in Iceland, we discovered the extreme quantities of lava that emerges to the surface in every eruption that happens in Iceland. We actually do use lava as a building material today. Concrete is made out of basalt lava in Iceland, but it's mixed with cement that is produced in a very energy intensive and polluting way. So our question is, why not use the lava in a molten state before it cools down as it comes up from the ground? The idea is that Iceland is a basalt rock that has been shaped by volcanic activity for over tens of millions of years. This activity has created various formations, mountains, caves, and tunnels. And what you see here are drone images from one of the eruptions that happened on Reykjanes in the past few years. These shots show very well how new lava melts through older layers of lava, and by that forms canyons and creates shapes a new landscape. An almost infinite amount of lava comes up in every eruption, not infinite, but enough to create the whole city in a matter of days. So this project is a cross section of Icelandic history, told through geological layers. It's interesting to look at this footage from Hekla eruption in the south of Iceland from 1947. Lava and eruptions, they've always been a destructive force through the ages, but Icelanders have lived in close proximity to it since the settlement. And as you might know, the last series of eruptions in Reykjanes happened around 800 years ago. Um, in our kind of thinking about Icelandic history, we say that the turning point of Iceland was when we found a way to turn the disadvantages into advantages. The volcanic activity that had harmed Icelanders since the land was settled was turned into geothermal heating that runs in veins through towns and cities, a project already starting on a large scale during the 1930s. Now we can grow food and go swimming in heated pools during winter times. We harness glacial rivers and volcanic steam to power electric vehicles in the city. So we're currently living the sci-fi of the 1900s, and that inspires us in our sci-fi project in the present. When we're in the middle of the event, it can be difficult to see opportunities. It's natural that we're focused on the first reaction. These events come without a warning and are enormous and shocking each time they happen. Like you can see here from the Westman Islands, where they tried their best to stop the lava flow or slow it down at least. But we believe now is the time to look ahead and use creative thinking and foresee how to react and use what flows out of the earth in large quantities. Up until now, we have used seawater and protective walls to save infrastructure, but very few experiments have been done in trying to harness the embedded energy and use of molten lava. In our project, we envision a future where we have found ways to utilize this resource, the material and its embedded energy, to create structures, buildings, and cities. In Iceland today, we're gaining knowledge on a day-to-day basis of how to monitor, predict, and divert the flow of lava. We have roads that cross new lava fields less than a week after it flows. We have construction machines working where the lava is still red and glowing. We have lava frequently flowing over paved roads with perfect access to do our first experiments on diverting and even casting from newly erupted lava. Our research questions that fuel the project revolve around how the different properties of lava in different states and compositions can have the same properties as mass-produced building materials as we know them today. And we were very lucky to be chosen as Iceland's first contribution to the Venice Biennale in Architecture 2025. And that kind of became a push for us to be able to develop this project further, to finally get some funding. And in short, this idea is that molten lava can be casted, formed in trenches, or even 3D printed with advanced technology of the future to create buildings and whole cities. We imagine the architecture, the city planning, and how people would live in this future city. The project is set in 2150, and we imagine a world where climate change has reached a new level and where technology has advanced. And a part of the exhibition is a film that we made, and we teamed up with Andrisnar Magnusson, who's an Icelandic writer, and he gave the people of this future city a voice, and they kind of tell us about this future world, and they talk about development in technology and societal change. And yeah, and then of course Jack also worked on the kind of soundscape and the music in this film. And here are just a few pictures from Venice, from the exhibition space where we presented our project. And with one part of the exhibition was this film, and then another part of it is this wall of screens where we kind of threw all our research onto the wall in the form of animations. These animations show the architecture that we imagine. They show the technology and the future kind of meteorological future of Iceland. And then we have a live stream of the eruption zone in Reykjanes. And one of those screens, or two of those screens, are dedicated to the lava flow simulations that we did in collaboration with Einat. And here you can see the code of one of the simulations running. And these are what we ended up making with the lava flow simulations. And we managed to use the simulations directly, or we managed to find a way to use 3D software like Blender that I use for my designs. And we managed to, with Jack, to kind of be able to almost just simulate it inside of that software so it could be visualized and rendered in 3D straight from the go, which was something that we were very interested in doing. Also, not just using these simulation tools, which are just really cool, but also to find a way to visualize them. And we're still always kind of thinking about what the next steps are in that. And you can kind of see a zoomed in view. This is all the same spot west of Grindavik. It's a system called Eldvörp that we just heard that a few Icelandic geologists were saying this one's the next system to go. So we thought maybe we could just use that spot to create our city. So we did a bunch of these sketches of these trenches in the landscape and simulate it. And it was a very interesting process. And Jack is probably going to talk about it a little bit more in a little bit. And yeah, we also looked into kind of the IPCC predictions about weather changes in volcanic activity in Iceland with the melting of glaciers and the kind of this weight getting lost on the landscape. A possible stop of the AMOC ocean stream, which would, yeah, might send us into an ice age, or I don't know what the latest science on that is, but yeah, so we just kind of started thinking about what the future of Iceland as a whole would look like. But in general, we're not really looking at this project being exclusively about lava, but also being about a threat turned into an advantage, a response to extreme climate or situations that are present everywhere around the world. Forest fires, extreme heat, wind, and rain. So lava forming is a concept that can be applied to other places facing extreme situations. Here you can see before and after. This is the before of the Blue Lagoon. See the parking lot and it's completely safe. And then you can kind of these images, these before and after images, kind of show the stark contrast. And here the parking lot is gone, and millions of cubic meters of material have flowed. And the scale is really hard to grasp, I think, especially if you're not into geology at all. Then this is, you can imagine almost the whole city just from that one eruption. And also, as architects, we want to envision how the city of the future would look like and how it would be built. We've seen the trenches and images before, but 3D printing is also an idea that we had. And this is kind of our most far out sci-fi idea, maybe, is that we thought about 3D printing could make sense as a method, but we don't think about we think the nozzle wouldn't just be like an XYZ axis like how it is today. So instead, we imagine a 3D printing robot that traverses the lava fields and kind of eats up the lava and then vomits it back out. And these robots kind of create this spiral building shape that is like this additive manufacturing process. And this is one of our proposals on how we could live in a lava castle. And then we imagined the clothes the people would wear in the city. We did some physical tests of lava casting and took some microscopic images to study them. And yeah, these are images here from the lava show in Iceland, where we did some experiments with casting from molten lava. Oh, sorry. And which was a really interesting process, and we're still gonna try to take further now. And here are some of the tests that you can see basalt in different states, fully crystallized rock, and then these glassy like structures. And you can see the iron being separated here from the basalt glass. Here are these stories from the inhabitants of the future city, written by Andresnær Magnusson and printed out. And here's a few stills from this film that we made. And then in January, we are going to bring this exhibition to Iceland in the Reykjavik Art Museum. So that's what we're working on now, and kind of trying to maybe push some things forward and do some more of these physical tests, do some larger scale testing with lava, and more kind of scientific tests. So yeah, that's it for me, I think.
Cool.
Thank you.
Yeah, and we can pause for a minute before I continue on if anyone has any questions for Arnar and the architecture side of the project.
Yeah, for sure.
Yeah. How is the thermal conductivity of your walls? I mean, you don't have a problem with heating in Iceland, but I can imagine that compared to other forms of building materials, it's not a very warm house until you start to really bring geothermal heat into it.
Mm-hmm. We actually this is something we also want to do a lot of tests on, but lava is really a good insulator if it's especially if it's in its porous state where it's light. And we think about this kind of material as, it can be a gradient that goes all the way from a structure, that concrete like strong crystallized rock, which is holds some structural value, and then it kind of turns into a more porous insulating material. And then of course it can be glassy, which could be like a kind of weather coat or like a cladding. And of course, yeah, of course, we'll have a lot of geothermal heat coming wherever we would make a lava city, so that would also help. But I'm not an expert on this, but what I've heard is that it's a really good insulator actually, or it can be. So
if you look at the lava tube, then once it's closed, it can retain its heat for kilometers. It can maybe even cool maybe 5-10 degrees over 10 kilometers of lava flow if it's in the tube.
But
So
how do you control your porosity? I mean, you have access to.
I mean, the lava itself is usually pretty porous. Yeah.
Mhm. Yeah, I think the one aspect we want to control the most, or trying to, is trying to make it crystallized. We want to make it into a structural material. That's like our main focus now, and we're doing a little bit of tests on that. Yeah, so usually it's porous. That's the easier part, maybe.
Arnar, I wanted to say that the lava show in Iceland is someone that for the really long timers here, you may have heard me speak about the Syracuse Lava Lab. So the artist from Syracuse, Bob, he collaborated with folks from Iceland, and now there's a show that you can see how they do that with the big furnace. But here from one of the early experiments, I have kind of a cast that we did lava flows in a rectangular metal channel. So I just put that on the table here because I have a slab about this big.
Oh, cool.
You see all the ropes and everything. So it's pretty heavy because that is not vesicular at all. And if you try to like rub your hand on it, you're probably gonna get cut because it is glass. So, but you can like slide it on the table and so others can see it. It's really heavy, but it's very dense.
It's beautiful. I have a question kind of for everyone in this room and you both. Are there like these open air experiments that have taken place where there are crystalline seeds introduced? How does that look like? What does that mean?
Ariana Soldati did some at Syracuse.
Oh, okay.
You can see some of she's done. Yeah, most of what I've done, they heated it up so much that there was no crystals left. But like you'd have to find something that would melt if you were trying to go for like what's the growing. Yeah, and they tried with like some people try with metal, but they usually sink down.
Okay.
So yes, but
Yeah.
but
Oh, that's coffee. Sorry, 1 second. Oh gosh.
Lava flows.
Klaus, you have some.
Okay, it's away from electronics. Oh my goodness, I can't go anywhere. I'll be right back.
Should be paper towels in the kitchen. Right there. Right behind that wall. Nope, right here, inside. I don't know what's up here yet.
I have a question while all the excitement is breaking around us. And that is, I can understand the incentive for this project in terms of the large amount of material which is available for the use.
Oy.
The part that I'm having difficulty with is understanding how you're going to have enough more.
This is my wrist.
Stuff, so if you're making bricks, the bricks can stack up and be inventory for a while.
We'll show the same things.
But I'm worried about how you're gonna make enough molds.
I'm sorry, I'm kind of having difficulty.
I'm so sorry.
Hearing.
I think
How
it's
are you
there.
going to make enough molds to capture all this in one shot? You don't get one shot at it, it's only mold once.
Yeah, exactly. We that's why we kind of think about, you know, like the most elegant way to build like whole out of this material, in our opinion, is to trenches that would just be a negative that comes out of the landscape, and the lava would flow, and it would cool into a grid that you could then build on top of with lighter material. So because the 70% of the CO2 emissions of a regular building, at least in Iceland, is concrete. It's always concrete. It's always a structural part or steel. So if we can kind of manage to create a CO2 zero emission, or just whatever emission would happen in a regular eruption, and we could build a whole city, then we could kind of we have like a actually sustainable city. But then also that's always a problem to, because you can see how lava flows. It's very difficult to imagine it going through these long channels that are tall, you know, that it'll always clog up and overflow, and the viscosity difference is so big. But then yeah, with the molds, we're actually doing some tests now with kind of steel molds, but yeah, those will like bend and get destroyed after a few tries. So we're thinking about ways to kind of do this in the most elegant way, not to mimic like industrial processes from today, but to kind of create something new that's specific to lava.
Out of what material do you make your 3D printer? Because after all, very high temperature that it has to handle.
Yeah, you would need like around like 1200 C or something. That's kind of our idea. Is that one is kind of, you know, maybe the least kind of developed, really, because we aren't really engineers. But the idea is that the robot can, you know, get its energy from traversing the lava fields. It'll capture the heat that is embedded in the material that it's stepping on, and then it can kind of create a system where it is able to remelt the lava that's like eating up, so it can vomit it back out.
Jack, do you wanna?
Yeah,
go
should we carry on? Yeah, thanks for all the questions so far. So
Yeah, thank you.
can people see my screen?
Yes.
All right. So yeah, my name's Jack. I have been living in Iceland for 4 years, and I have now a design studio that is called Afkvæðueki, which is the Icelandic phrase for why not. And this was definitely kind of like a why not project when someone comes to you with such a amazing proposal and context in which to exhibit. So I'm gonna kind of like take you through a little bit chronologically how we managed to use Victor project and the sort of modeling platform. You know, I am also not any kind of volcanologist, and this was the first time I've ever used GIS technologies. Luckily, Arnar is very good with Blender. So that was kind of a place where we knew we could try and do some good work. But the question was how to arrive at something that is in line with the rest of the beautiful aesthetics of the project. But when we are kind of starting out from this scientific platform where the objective is you know, more clinical in terms of information presentation. And of course, there's mainly data being produced by the simulation. There's data in the elevation model, and we have architectural data that all needs to be sort of massaged and translated to be able to work with each other. So, so really, the way we've managed to achieve this is by creating our own Blender kind of plugins or add-ons. And the first task was to modify some elevation models of Iceland to include architectural designs. And so this started with the most basic kind of structures that Arnar drew, and then me and my intern at the time were trying to figure out how to import this data into the Victor environment as elevation model. And we went through various stages of trying to figure out what data we could get from where and get it into the 3D environment and so on. But eventually we managed to get our first bit of data back from the simulation environment into Blender via another Blender plugin, which I'll show in a second. But as you can see, this is still, you know, quite low resolution spatial data and low resolution simulation as well. So we still had quite a lot of work to do. And apart from anything else, you can see here that there's a pool of lava at the bottom of the picture, which is supposed to flow down these trenches, and has decided to do something quite different. And that became also one of the big challenges of the project. But yeah, we eventually figured out how to get the highest sort of elevation model resolution that we could achieve. So here you can see more of the context of where we were simulating. So there's the town of Grindavik there, and you can kind of see to the top right, that's where you're getting towards the existing like volcanic sites of the last few years. And then Eldvorp is off over to the northwest, slightly uphill towards this ridge. And so that's where we were sort of doing our speculative design. And yeah, so of course in the Victor project you have all of these different models, and we were trying to use Mr. Lava Lubba because it's the main model that they use in Iceland in the meteorological office. And actually that's how we got in touch with ANAT via Gro Pedersen, who recommended that we check out the Victor project. So this is an attempt at using Mr. Lava Lava with our trenches, and it kind of went hilariously bad like this for a good few months, I would say. But I just thought these are some quite nice pieces of generative art that I thought would be fun to share. Here's me just trying to try all different kinds of parameter types to understand how these models work, and even that kind of became part of the story of the project in a way of like, how do we understand lava? How do we understand its dynamics? And how can that interoperate with architectural scale problems and designs? So again, here's a few more from the waste bin. And somehow reminiscent of some of the architectural forms that you saw in the film as well. So eventually we kind of gave up on Mr. Lava Lava, and we went back to the more simple molasses model, which was able to kind of like obey our trench designs, but even still we had to go do a lot of iteration. Here you can see, as Arnar was saying, you know, the trenches are they're often like too narrow, not tall enough, and so on. So there's a lot of heavy iteration, and slowly getting towards a full pipeline where we could quickly make an architectural change, run a simulation, retrieve the data back, and revisualize it in a more sort of aesthetic way. So you can see the plots getting slightly more sophisticated as we went on. And I think at this point, I was emailing Arnar and Sam quite constantly with requests for help with tuning parameters and so on. So thanks again, Arnar, for your patience. But once we kind of had a workflow together, then we branched out in terms of the actual design of these trenches. So this is a figure from a book about fractals in African architecture from Ron Eglash. And here you can see a sort of village design using fractal mathematical ideas. So then at that point, we were just trying lots of different forms. This was actually helping us understand the limitations of each model, or understanding how each model sort of projected the lava flow in different ways across these different kinds of forms. Yeah, and then this led to another tool for Blender. So a tool that could allow us to re-import data back in from the simulation world into Blender. And then here finally we're getting more towards the final product. So now you can see we've gone more to the trench design, where it's sculpted out as a negative out of the ground, as Arnar was saying. And here on the right you can see the village of Grindavik. And then if I play this one, hopefully you can kind of see these are like the frames of the model output. And yeah, there was a lot of work that we had to do with because these models don't necessarily let you do this kind of like time stepping that you're seeing here. And so we had to basically run the same model with the same setup as many times as we wanted frames out. So this became quite a complicated Python code jungle, so to speak. And here's this is what my laptop looked like in the run up to the final few weeks, running 6 different molasses simulations at the same time for different trench designs and different parameters, and trying to use the multi-core processors on the Victor servers as efficiently as possible. And after all that, we finally got there, and here's again the sort of final render ran back through the Blender 3D environment with 6 different trench designs. And so, of course, we could have used simulations from the film industry or the computer graphics industry, but it was quite important for us to use the same models that scientists are using today, so that it becomes part of the dialogue. So it was quite a lot of sweat, but yeah, but very, very satisfying in the end. And then I also just want to quickly mention about the soundtrack, because someone, sorry, I've forgotten your name, mentioned the soundtrack. And so the way we did the sound effects for the film with these robots going across the lava is we took a record and a data set of recordings of the actual lava flow in Reykjanes, which was turned into some music by Ben Frost and Francesco Fabrice. And we trained an audio generation model on these recordings that we could then kind of like puppeteer. So the sounds that you hear in the film of the robots moving actually are themselves coming from lava as well. And then finally, in terms of the next steps, we really would like to make things more real-time and interactive, and one of my projects has been in this space of creating sort of creative coding environments where people can explore self-organizing systems and artificial life, kind of complex systems, but in a kind of interactive and fun way. So part of what I've been doing in the background is trying to figure out how to do some real-time simulations of lava that can be also interactive. And you know, you could imagine the upcoming exhibition in January having an interactive element to it in terms of allowing people to shape their own lava trenches, or like tweaking the simulation parameters for how much lava is emitted and so on. So here's this is flying over the Reykjanes Peninsula elevation model using a PlayStation controller. There's one sort of element in that process. And then here's some tests of different ways of doing simple real-time lava simulations, completely inaccurate, but kind of fun. There's like 4 different little approaches here. And yeah, we also made more Blender plugins for trying to do all this stuff in the place where the architectural design actually happens, which is Blender. And then finally, here's my very first attempt at an actual lava simulation. So it's quite modest and unimpressive compared to those in the Victor platform, but it runs in real time. So who knows, maybe it will be something people can play with in the future. So yeah, that's it really. And once again, just want to say thank you to Einat and the Victor Project for your support, which just added such a, in a way, quite subtle, but I think also very impactful element to this this project. So I hope we can also continue collaborating as well.
Well, thank you for using it for something so creative and imaginative. Like we would have never thought to do that, right? But it's so cool how it turned out.
I will say fighting with the models that way really just does sound like the life of a scientist. I was gonna say, you got a pretty good crash course in what we do, having to build a random tool to make something, format the data right, and a lot of bad plots. I keep a folder.
Yeah, when you were talking about the pain, there was a lot of empathetic nodding.
Yeah. This was my life for like a good 4 months of the year, so I definitely feel you on that one.
What's cool about the artistic process is you get to talk about all the parts that didn't work. You don't just show the pretty figure at the end.
Yeah, that's true.
I have a question for, I guess, all of you as collaborators. I feel like some of the tools that you guys developed together, especially the Blender plugins to the, or is using Blender plugins to reinterpret like the DEM models, is very cool in terms of furthering scientific communication of like your work, right?
Yeah, no, I was looking at it and I think we could definitely use some of these tools for, you know, the actual scientific research that will provide, rather than putting just that kind of dry gray map, to use some of these tools to create some like extra content.
Yeah, scientists love pretty pictures too. I feel like, you know, it's good for outreach, but even just for communication.
Yeah, I mean, the scientists, the public, the funders.
A lot, and even like the toying with input parameters is a very interesting idea. And maybe this is probably, you don't have to have this conversation now, but I'd be really curious on like what input parameters made the trenches work for you guys, right? Like what are the specific things that you had to tune that you were eventually like, oh, okay, the viscosity has to be super low, or the, you know, etc.
Yeah, we basically made the trenches obscenely large in the end. I think that the main limitation for me was that I just didn't know enough to use like the more advanced models, like the like Lava 2D and so on, where it's more physically accurate at smaller scales potentially. So there was a lot of constraints, and in the end, the molasses, the quite simple cellular automata models were the ones that we could use quick enough and iterate fast enough with. But yeah, at a high level, I completely agree about like what you're saying. I mean, and partly what Arnar and myself wanted to ask everyone in the room, I guess, is you know, from anything that you've seen us doing, like in terms of what I'm doing on working with today's tools, but also what Arnar is presenting as kind of emerging methodologies, how might you as scientists benefit from using and iterating on some of these tools with us in your own work, which you've already started to address there, but that's definitely something we're excited about as well.
Yeah, Alex, your question, one of the, like, at the very beginning, when we started stuff, like thinking what the exhibit's gonna look like, we thought, oh, it'd be so cool if it was interactive and people could, you know, have a slider for the time or a slider for viscosity or something, and it wouldn't even have to be calculated in real time, but you know, the
library.
Yeah, it can be a library of model outputs, and then they can just select out of a few kind of sets of parameters. That's still to be done, but I think it'll be cool to have kind of like a physical lava game.
Yep.
I mean, for the trench design, I mean, that may be something. So at the Lamont Open House, every year we do an exhibit where we have a little town, and the audience puts blocks to protect the town from the lava that's coming. And I'm thinking maybe next time we can change it just a little bit and they build trenches to create a new city from this material. And we use wax because it's very real time, it solidifies quickly. So now that's an idea.
That sounds fantastic. And yeah, we would love to have, you know, like part of our exhibition where people can do exactly that, and there's lots of interesting technologies that might get us there. I think the tricky part is the more you try and do real-time simulation, obviously the less accuracy you can achieve, unless you have like an offline database of outputs or something like that. But I think it seems like now there's these kind of machine learning systems that learn offline how to mimic a complex, accurate simulation, and then you have a very fast real-time inference engine that is able to do the prediction without all the heavy computation. So that's what I'm kind of researching next, in an equally beginner fashion as with all of this stuff. So if anyone is knowledgeable about anything in that domain, I would love to learn more about that as well.
Well, I have no.
I love that idea.
Oops. I have a question.
You go ahead.
For, in terms of what you're actually creating is more an urban planning project rather than immediately a living habitat. So have you gotten urban planners involved into that? Because you know you have to create not just streets, which are the trenches, but the entire infrastructure that has to come with it. And so it seems you create a layout of a city, but you're very far from creating a livable city. So the question is, what elements have to come next to make these really cities that are livable?
Yeah, I think it's it's a very interesting kind of thought experiment in this way, because it's so much material that erupts in a few weeks, and after 2 weeks more you'll have a whole city and nobody lives there. It's probably pretty dangerous to move in, even though it stopped erupting. We don't know how long it'll take for everything to fully cool down, and you don't really know when the next eruption will take place either. And we have a lot of examples from history, I think, of these big city planning projects where maybe things haven't gone that well, or like today we don't really see those cities as good habitats to live in, like in Brasilia, and some ideas that were had about Paris in the 1930s, where they wanted to kind of just demolish all the old city and create a big kind of concrete city. So I think it's difficult to kind of take just a few people to design for potentially like a few 100,000 people in 1 week. So I think it's just an ongoing thing. I think we kind of have to just experiment, I think, and our idea is really also that this material is not to be sold for profit. There's not one company that should own the lava and just sell apartments and make a lot of money. We want this to be a material that is owned by the people that live near the volcano, the people of Iceland, and that this would be a kind of city that would be owned by the population, and they would have some say in also the design of the city itself. So I think that's always that's something that could kind of make it a more human, livable city, is by getting everyone involved that is going to live there eventually in the design. And I think also one thing that's pretty interesting, which makes it kind of also unlivable, a kind of hostile place. And Andris Nair, the writer who works with us, he's really good at, just like living in this imagined future and telling stories from it. And one of his stories, he talks about this gardener that is a refugee from a country we don't specify, but she moves to Iceland. She moves into this city, and it's a new city at that point, and it's all black, there's no vegetation, it's just black lava rock, and she's really scared. She doesn't really like it. But then after maybe 10 years, it starts to become green. The moss starts growing on the lava, and the plants start to grow. And that's what really interests me, is just thinking about how all of this architecture will be kind of unique. I don't know if it's an answer to your question, but it's just a fun thing to think about.
Thank you. There's no more questions. I have the contact information if anybody has more questions or want to get in touch. No. Yeah, thank you. Thank you.
Thank you.
Thanks for your attention. And yeah, please,
thank you
please
so
do
much.
reach out.
Thanks. Good questions. Yeah, we would love that.
Yeah,
we want to kind of we want to really make stuff that's in collaboration with people that know what they're talking about.
And yeah, also if any of you are thinking about a visit to Iceland, then definitely reach out, because yeah, would be great to meet up as well.
Yeah, the exhibition is opens on January 24th. If anyone wants to come to Iceland
Say
in
hello,
January.
Paul Einarsson, if you know him. Do you know Paul Einarsson?
I'm sorry?
There's only
He's
Thor
a
Einarsson.
here from Vermont, and he is in the, well, I guess a branch of the university, but also related to the meteorological office. So he's a seismologist / volcanologist.
quite a few of those in Iceland. So, I know specifically this one. All right. Yeah, great. So we're now gonna talk about EdgeCom, and also reading the paper, I realize it's not part of the ARG, so forget that.
Yeah.
I thought it's a located in Alaska, might as well, right?
No, EdgeCom is-
Yeah, all right.
Thank you.
Okay. Thanks a lot, everyone. See you.
Oh yeah, I'll stop
Okay.
recording.
Thank you.
Bye.
That was so cool.
Yeah.
Yeah.